Hi, mathletes. In this lesson, we are writing equations of tables. At the end, you will be able to write an equation of a line given a table of values. In this lesson, we are going to focus on linear functions, and the equation that we're going to focus on is point-slope form. We have been doing point-slope form where it looked like this because it came from the slope formula. And I want to point out that we can write an equation that looks like this simply by taking this minus y value, and if we want to move it to the other side to get rid of that, we would want to add that value. So I could add this y1, and if I do it to one side, I have to do it in the other. A minus and a plus are opposites, they cancel out, and that would leave us this formula right here. Why would we do that? We would do that because now this pattern is the same pattern where we take the opposite of x for our point and the same value for y, just like we do for the HK vertex for absolute value functions and quadratic functions. So some students like to think of the form like this. These are, remember, lines can be written in many forms, and some students find it more helpful to think of it like this. So we'll talk about it both ways in this lesson. So let's remind ourselves what the components of this equation are. So the m value, regardless of which equation you want to use, is always related to your rate of change or your slope. So mark this on your paper. Remember, that is rise over run. And if you want to also put that slope, you may do that as well. However you want to remember that, but you should have rate of change and rise over run for sure. You can also put down that that's the change in y over the change in x, if that is helpful as well. In addition to your rate of change, this equation gives you a point, and we often think of this as our starting point for graphing. It can be any point on the line. And the thing you have to remember when you're writing your ordered pair is that we have to look at what goes with the x. So I'm looking at each of these with the x has a subtraction. That means that we are going to have the opposite value here. So write that down of what you see in the equation. We'll go through some examples, but you remember this hopefully from last unit. And then the y value, you can look here when we write it in this point slope form, how we've always done that from slope, it is also the opposite. So you take the opposite of both of those, and it's the negative in there, the subtraction in here, that is what makes you do the opposite. That always indicates that, just like in this equation. When we have just a plus, when we have just an addition, you're going to take that y value as it is. And again, that we will show with some examples from this graph that we have right here. So looking at our graph, we can go between any 2 points to do our rise over run. And you can see that as I'm writing this, I'm going up 2 over 3. And our graph is going up, so I know that this is my rate of change, or my slope is positive 2 over 3 because my graph is increasing, and I'm going up 2 to the right 3 between points. Now, for choosing a point, I can choose any point on this graph. I often like to choose positive points just because I think that that's easier, but it doesn't really matter what points that you choose. I want to highlight that I'm not choosing my y-intercept because I can't clearly see where my y-intercept is. If I look at right here where my cursor is, it's somewhere between 4 and 5, and we don't have an exact value. Maybe it's 2/3. It's really hard to tell. We're not going to use that because we don't know exactly what that is. So we're going to pick a point that we do know. I'm going to use this point 2, 6 right here where my x value is 2 and my y value is 6. So my equation, if I use point slope form, is going to be y minus 6 because we do the opposite of what we see here. I'm using this first equation, equals my slope, which is 2/3, and then x minus my x value, which is 2. notice that you see the opposite. So in my ordered pair, my x is positive and I have minus 2 with my x here. My y value is positive, so I have a negative here when I'm using that traditional point slope form. Now, some students may want to transition to this form so that the pattern is the same across all of our function types. And if you do that, you would have, instead of y minus 6, you are going to have y equals, and then 2/3 x minus 2, because that part all is the same. It's as if we added that minus 6 to the other side, so it's plus 6. And you can see that in the equation here, it is built in positive y1 or positive the y value, and so we would take it the same as you see in the pattern, just like we do for the vertex for absolute value and quadratics. A reminder that these are not the only equations. This is the equation for when we pick this point, but there's infinitely many points along the line, but there's some nice points at grid marks, and we could have used any one of those points. So how can we transfer our knowledge of writing equations from a graph to writing equations from a table? And we have some steps here. We want to find the rate of change. On a table, you are going to do the change in x and change in y like we did in Unit 1, versus in a graph, you count the rise over run by going up and over on your line. Hopefully we're in the pattern that every time we see a table, we're looking for patterns, and we're going to look here to see what it is. And from -7 to -4 is increasing by 3. From -4 to -1 is also increasing by 3. Remember to pull out your number line if it isn't obvious to you that each of these values is increasing by 3. For y, we're also increasing. I can see that these numbers are getting bigger. This time they're increasing by 2. Let's make sure that it's the same all the way down our table. From 2 to 4 is increasing by 2. All of these are increasing by 2. And so that tells us that our rate of change is the change in y over the change in x, so our rate of change is 2/3. You will notice that this is the same rate of change as our graph above, and you can see that these ordered pairs correspond to the points on that graph. So this is going to be just looking at writing the equation from a different context, but we're going to get those same equations from above. So for choosing any point, we can pick any point. Some students like to pick just the top point that's in their table. That's fine. Or like I did above, I chose a positive one. Because we already chose 2, 6 above, I'm going to choose 2, 6 again, just because you can see that the process is exactly the same. But we could have picked any one of those. And then writing our equation, I like to have my form here. I'm going to use both the y equals m times x minus x1 plus y1, but I'm going to choose to put them both ways, both in the original point slope form and the modified point slope form, just in case you like to see those in that way. And so we have the same slope as above and the same point above. You can write it either way. So y minus our y value equals our slope, and then x minus the x value, which was 2 in this case. And again, if you want to see that written out, it is not a bad idea to remind yourself that an ordered pair is xy. So that was one of our equations. The other equation would just be as if we put that -6 and we added it, so it would go to the other side of our equation, doing a little algebra to manipulate that. So either one of these would be correct. Again, if we chose a different point, so let's say I chose the point -7, 0, that top point, I would have y minus 0 equals 2/3, and then I'd have x minus the -7, which is the same thing as adding 7, because remember, these should be opposites. And if I use the other form, actually nothing really changes much, because if I add that 0 to the other side, it doesn't change. So you could also see the equation looking like this. Your equation is correct if it accurately goes through all the points in the table. So you may have your different form than somebody else, and that's going to be okay as long as it is truly an equation for that table. a quick summary here. Look first to see what you noticed about the table. See if there's any patterns that jump out at you, because if you can see the relationship and write that as an equation that represents the points, you don't have to go through these steps. Most of the time, it may be more complicated and you want to go through these steps, but if you see a pattern right away, that's fine. So if nothing obvious jumps out, you're going to go through these steps. These steps can be found on the next page for the two examples that you're going to work through on your own or with your partner at your table. So the first step is to find the rate of change from your table. And we know that we do that by marking the change in X and change in Y, and then writing that as a ratio. Just to remind ourselves, that is always going to be the change in Y over the change in X, or if you want to think of it as rise over run. But that's what you're going to find first. You're going to find a point, which is just X1, Y1. That's any point on the graph. That's how it's denoted with the little subscripts. Yes, it can be any point. I often choose positives, but you don't have to. If you have the y-intercept, you have something that's 0 and then a number, that's the y-intercept, you can use y equals mx plus b form. And then finally, you're going to use your rate of change and your point to write your equation. And so you're going to use often point slope form or the modified point slope form, but you can also use y equals mx plus b.